Welcome to today's webinar, Beyond Audiograms, Revolutionizing Hearing Aid Fitting with the ACT Test, sponsored by Oticon and Interacoustics. My name is Melanie Hamilton-Bassich. I'm the Chief Editor of the Hearing Review, and I'll be serving as today's moderator. We will be having a Q&A at the very end of our presentation, so during the presentation, feel free to submit your questions. Our speakers today are Ashley Hughes, AUD, who is the main point of contact for all audiometry, impedance, OAE, hearing aid fitting, and telehealth solutions at Interacoustics, and Virginia Ramachandran, AUD, PhD, the head of audiology at Oticon. I'll hand the presentation over to Ashley Hughes now so that she can begin.
Hello, everyone. Thank you for joining us today. My name is Ashley Hughes, and I will be starting off our presentation, Beyond Audiograms, Revolutionizing Hearing Aid Fitting with the ACT Test. As mentioned, I will be starting the talk today, and then about halfway through, I will be handing it off to Dr. Ramachandran from Oticon. Thank you again for joining today. During our time together, I'll be taking you, at least at the beginning of our time together, through the journey of ACT, from diagnostic testing through hearing aid fitting. But before we start talking about why ACT, I'd like to take some time to give you a quick introduction of what ACT is, so we can set the stage for everything to come, and we're all on the same page throughout the presentation today. ACT, or the Audible Contrast Threshold Test, is a non-linguistic test that takes approximately 2 minutes to perform, and the value that you get can directly guide your hearing aid fittings. One thing that differentiates ACT from other available tests is that it is presented super threshold. So to perform ACT, you have to first perform pure tone air conduction audiometry at 250 Hertz, 500 Hertz, 1000, 2000, and 4000 Hertz. This is again to ensure that the stimulus is presented super threshold across the frequency range. When performing ACT, the patient hears noise that's presented at least 15 dB SL across the previously mentioned frequency range. They're asked to press the button every time they hear the siren, which is actually modulated noise superimposed on top of that bass noise. We're searching for the threshold, or the value where the patient can just detect the modulation 50% of the time on an ascending trial, following the modified Houston-Westlake bracketing approach, making it an easy test for you as the clinician to learn and for your patient to follow. And the value that you get when performing ACT is highly correlated to predicted aided speech and noise testing in an ecologically valid environment, or predicted performance and noise with hearing aids in the real world. So now we'll take a step back and we'll talk about what information do we not get from audiometry. So audiometry is an important clinical tool, but there are aspects of hearing that the audiogram doesn't cover. We do get some information from audiometry. Of course, we're finding out about audibility, but we're not seeing the whole picture. And we're not really finding out how the patient performs in their everyday environments. The ability to hear tones in quiet doesn't necessarily reflect the typical demands that our patients are experiencing in everyday conversational situations. And when we use audiometry to fit hearing aids, which is of course a requirement, it's limited in the guidance that it gives us in how we should set those advanced features on our hearing aids. Speech audiometry is something that many of us perform at times to supplement pure tone audiometry. And performing these tests does provide the clinician with more information. There are some strengths and some benefits that we get from speech audiometry, but there are also some limitations to it. So you'll see some of those listed here. It's very relatable for the patient. They come to you, they tell you they're struggling to hear a noise, and you task that system, and they know that you did. It can help build rapport, and it can help cross-check. Maybe you want to check your PTA SRT agreement. Can help us with counseling. It's a very valuable tool, but there are some limitations to it. Time is extremely valuable in the clinic, and speech testing can take a significant amount of time. Also, the starting level that we're presenting at for word recognition drastically varies depending on the clinician that you're talking to. Many of us aren't going to have the ability to set up our booths to test our patients in an ecologically valid fashion, really capturing how they're performing in the real world. And then also, if a patient's native language isn't the same as ours, there are limitations to our ability to test. And even if we have recorded speech, there are limitations to our ability to score when a patient is being tested in a language that we don't speak. So I just want you to think about your average day in the clinic. Are you regularly performing pure tone audiometry? At this point, most people would be raising their hand if we were in a room. Speech and quiet testing. Again, we typically still see most clinicians performing this. When we move on to speech and noise testing, typically we're seeing a few less people doing this than the previously mentioned test. And then when we talk about speech testing, regardless of our patient's native language, we're seeing more of those hands drop down, understandably. And this last one, performing speech and noise testing aided in an environment that mimics the patient's real world situation. So noise coming from, speech or the desired signal coming from one direction and noise coming from around the patient. Most people aren't able to do this clinically. It's time consuming. It takes a more complex speaker setup. And so it just doesn't really fit in our typical clinical workflow. So why ACT and why now? Before the introduction of ACT, hearing aids were fitted based on audiometric thresholds. But we know that hearing loss is far more than just our ability to detect soft sounds in a quiet environment. And we have been searching for well over a decade for a diagnostic test that can take us and our patients beyond the audiogram. And until ACT was introduced, we really just didn't have that test. We didn't have the predictive power of how our patients were going to perform with hearing aids and noise. And with ACT, we're able to change this. We know that the audiogram is vital. It is mandatory for us to get hearing aid prescription targets, but we're not getting an idea of speech and noise abilities from the pure tone audiogram. Speech audiometry is a great addition, but as we already discussed, there are some limitations to it. So if you think of the audiogram as a measure of the quantity of a patient's hearing, ACT is a measure of the quality of the patient's hearing. And if we combine these two, we have a much clearer picture of how our patients are going to perform with their hearing aids and how we can help them optimize their amplification. We're going to take a moment to review ACT and the guiding principles behind it, along with a very high-level overview of the research that led us to developing ACT as a clinical tool. So where did this all begin? We're not going to spend too much time on this. There are plenty of resources online if you'd like to dig deeper into the research behind ACT. But it began in the 2010s. Research showed a strong correlation between a test of something similar to ACT and speech and noise measurements. And that test is called spectro-temporal modulation. Spectro-temporal modulation is when an unmodulated sound has a modulated sound superimposed on top of it. There were limitations to the original STM test. It was difficult to distinguish between the sounds, and the test itself was too long, so it wasn't clinically viable. And so Interacoustics and Oticon took this information and started the journey of developing ACT as we know it today. On the screen right now, on the left-hand side, you can see a speech spectrogram of a hint sentence from the hearing and noise test. And this shows us the characteristic patterns across frequency and time. You can see some similarities between the spectrogram on the left and that on the right, which is of the ACT stimulus. So again, we have modulations that are imposed on top of a noise signal. So we get a similar spectrogram that we get from speech, but in a more controlled and structured fashion. During the presentation today, we're going to drop some links so that if you want to hear the ACT stimulus, you'll be able to hear that. So now we're going to fast forward to the diagnostic implementation of ACT, which again has really unleashed the potential of what we can get from spectro-temporal modulation. As you can see, the guiding principles behind the implementation in the software were, number one, to ensure the correct paradigm was used for the study. We adjusted to a 2 and 4 dB step size instead of the traditional 5 and 10 that we use with pure tone audiometry. and that was to balance speed and accuracy of the results. We're following a modified Houston-Westlake bracketing approach, mimicking pure tone audiometry as close as possible, easing the learning curve for both the patient and the clinician. And there's also compensation for audibility based on the audiogram, again, ensuring that the entire stimulus is presented super threshold. And then we're able to objectively identify a starting intensity for the ACT test. So after this decade and a half of research, what makes ACT so special? We have a foundation for a better first fit. When you're working with Oticon hearing aids, and Dr. Ramachandran will talk about this a bit later, you'll have the option to automatically transfer and apply the ACT value into the fitting software so that the adaptive features on the hearing aid will be automatically prescribed for that patient based on their ACT value. It is the first ever language independent diagnostic test predicting speech and noise ability with hearing aids. It's conducted in a similar fashion to pure tone audiometry, making it easy for, again, the patient and the clinician. And compared to other speech and noise tests, which can take a fair bit of time for setup and consultation, ACT takes on average 2 minutes to perform. So after looking at all of this, I'm going to walk you through what the software will look like when you're performing ACT and what it means to you. We're also going to drop a link in the chat so that you can take a look at a video of ACT being performed. Right here, you can see a software close-up of the ACT test in the inner acoustic software. On the x-axis, you can see presentations with a line at 25. And on the y-axis is the dB-NCL scale. That's normative contrast level. There's a vertical line at 25 presentations because this is where you begin to risk patient fatigue. In order to avoid hitting or going over 25 presentations, it's important not to time lock the patient during the test. On the y-axis, again, you have dB-NCL, that's normalized contrast level, normalized because this test is normalized based on how a patient with normal hearing will perform at 0 dB-NCL. And contrast level is what we're searching for, the contrast between the modulated noise and that bass noise that the patient can just detect 50% of the time on an ascending trial. Channel 1 and channel 2 will default to the appropriate starting intensity based on the patient's audiogram, one routed to each ear. The test will always start visually lowest or at the highest NCL, 16 dB-NCL. And as the NCL value decreases, the modulation is more difficult to detect. So there's less of a difference between the modulated noise and the bass noise. On the screen now, you can see a completed ACT trace. You can also see here that with an asymmetric loss, you may end up with an asymmetric presentation level, and that is as expected. When the clinician introduces the modulation, the software will automatically determine if the patient responded or not based on the timing of the presentation and the response. A correct response is a black filled-in circle, and an outlined circle would be considered a miss. Every time the patient gets it correct, the clinician will make it 4 dB-NCL more difficult, or 2 steps. And when they miss it, the clinician will make it 2 dB-NCL easier, or 1 step easier, following the modified Houston-Westlake bracketing approach. So again, using 2 and 4 dB step sizes instead of 5 and 10. Note that the clinician is not adjusting the intensity of channels 1 and 2, but rather the difference between the modulated signal and the bass noise. When the patient responds correctly at the same intensity 3 of 5 times on an ascending trial, the software will automatically stop and provide you with the ACT value. So in this case, we can see 1, 2, 3, and so the software stopped, and it gave us an ACT value of 3.9. Some of you might be looking at this screen and thinking, well, we got 3 responses at 4, so why isn't the ACT value 4? So let's look a little bit closer at where the ACT value comes from. Within the software, you can also take a look at the psychometric function, which will plot out all of the correct responses. The value at 72.4% is the ACT value. And so you might sometimes notice that there's a difference between the ACT value and an average. And that's because when we're pulling from the psychometric function, we're able to get a more precise value. Once you have the ACT value, you can click on guidance to see the ACT value ranges, where your patient falls within those ranges, and the fitting advice. And we'll look at those closer in just a couple minutes. So we've talked a little bit about what ACT is and how you do it. Let's talk a little bit about what it gives you as a clinician. Why might you want to have access to ACT? There are many advantages to performing ACT, but to put it simply, the clinical advantage is that ACT is a proxy to an aided speech and noise test. It is a test that we can perform in 2 minutes, a non-linguistic test that tells us how our patients are likely to perform with hearing aids in noise in the real world. And by making sure the test is presented super threshold, we know that it is clearly audible. And in some ways, we can think of it like we're performing the test aided to begin with. This is why we get such an accurate, reliable result of aided predicted speech and noise performance. With all this information, you might be wondering, okay, great, I have an ACT value. What do I do with it now? Generally speaking, the greater the ACT value, the more help that your patient will need from hearing aids in noise. There's 2 different ways that you can use the ACT value right now. You can either use the automatic transfer into hearing aid software when it's available, and Dr. Ramachandran will be able to get more into that in just a couple minutes. If that option isn't available, you can follow the guidance that we have provided here. With this guidance, we have 4 statements followed with what steps you might want to take for your patient. And so we have different areas where a patient might fall, ranging from normal to severe. As we see the ACT value go up, generally speaking, you're going to want to adjust those help in noise features, making them a little bit more aggressive, and perhaps discussing additional accessories depending on the patients and their needs. So if we go back and think about hearing aid fittings as they existed prior to the introduction of ACT, 2 patients with the same audiogram, same age, might leave the office with the same help in noise settings, or the clinician will be making some subjective decisions based on the audiogram or some other supplemental information, or perhaps some information that the patient shared about difficult listening situations. With the introduction of ACT, we have a more accurate prediction of speech and noise performance with the hearing aids up front. We can set expectations for our patients better with this and improve first fittings. And if we take a look at our patient on the left here, we now have the confidence to pull back on those advanced features on the hearing aids at the first appointment, instead of waiting for a follow-up appointment. And then if we take a look at our patient on the right, we have the confidence to do the exact opposite. Crank up the advanced features, discuss a remote microphone, and help our patients be as successful as possible from day one. And now I'm going to hand it off to Dr. Ramachandran, Head of Audiology at Oticon, to tell you more about how this can help your patient fittings.
Wonderful, thank you. I just need to share here just a moment. Can you give me a verbal if I'm sharing the correct screen?
Not right now.
Oh, not yet. Okay, thank you.
Now we're just seeing it with the slides, but you just need to, there we go. Looks great.
All right, thank you very much. All right, thank you, Ashley, and really appreciate you going through all of that. As Dr. Hughes said, there's a link that's now been put into the chat. So if you would like to see that ACT test in a recorded version, you can hear what the stimuli sound like and be able to explore that a little bit further. You can go ahead and do that following the session. We'll also be able to include some links for more information about the diagnostic use of ACT from the Interacoustics website as well. And then one thing which I'll kind of refer back to a little bit later is a an article that was recently published, actually yesterday, on the Hearing Review website about clinical feasibility of using the audible contrast threshold. So this was done at Henry Ford Hospital in the Detroit area. They have many locations, and so they were able to actually conduct the ACT test on their first 100 or so patients and give an overview of what that ended up looking like in terms of clinical feasibility, as well as what the results looked like for those patients. Because I know that anytime we think about implementing a new assessment in our clinical protocol, that's a big ask for a clinician, right? And so you probably need a little bit of confidence that this is in fact clinically feasible in a real world clinical setting. And that's really what the aim of that project was, is to really understand that clinical feasibility. They did not in that go into utilizing it with the hearing aid fittings, which is actually what I'm going to be talking about next. So that's why I wanted to mention it right here. So I'm going to talk about implementation of the audible contrast threshold test into fitting hearing aids, and specifically with the Oticon hearing aids, because the research that we conducted was specific to the Oticon devices, and the implementation is within the Genie software. Now, you could use the ACT information that you gain about the patient's performance in noise for other purposes as well. But we just have the evidence base for that right now with the devices that we currently have, including the Oticon Real and Oticon Intent devices. And one of the things that, when I think about doing speech and noise testing, it provides a lot of valuable information, but there are limitations in addition to doing the test. There's also some limitations as far as what would we do with that information once we have it. And so that's the real crux of this, is when you do a diagnostic test, what's the purpose? How are you going to use it in the end? That's where I think the ACT test really shines in comparison to other things that are available to us. It's not that those things are not good or not something we should do. We absolutely can use these as complementary to one another. But what the ACT value provides us is a way to really personalize the hearing aid fitting to provide an evidence-based way to approach your hearing and noise features. That really is not something that we've had in the past. When you go in any manufacturer software, it can be very difficult to know just how much reduction of noise they need, just how much directionality they need, in terms of really getting them the signal to noise ratio that's most appropriate for them. Sometimes people will ask, well, shouldn't I just maybe max out the settings and give them the very best signal to noise ratio possible? That is feasible and will work for some people, but overall, it can cause some challenges with the sound quality of devices. So our goal is to have as natural of a sound quality as possible, limit artifacts, and have it be a really comfortable experience for the patient, but to also give them the signal to noise ratio that's required for them to be able to do what they want to do and to perform how they would like to. So that's the purpose behind using ACT with our software and with our hearing aid fittings, is really to have an evidence-based way to program these devices to have the optimal support in noise. So before we get into that implementation in the software, there are a couple other research questions that we wanted to evaluate from Oticon's perspective before we began to implement this further. So three research questions up here. The first, I'm gonna go over the results for and how this study was set up. So the question is, can ACT increase the prediction of speech and noise ability substantially compared to the audiogram alone? Now, as Ashley said, the audiogram provides very, very valuable information because audibility is incredibly important to your ability to communicate effectively. But that's only part of the picture, right? Because the ability to hear a noise can be difficult for people relative to their performance on the audiogram. And so we wanted to know, can this test us to predict this even further. And so this study was conducted in multiple sites. So the testing was developed in predominantly in Danish, and so we wanted to understand, could this translate easily into other languages? So the study was conducted in Germany and Japan, which are very different types of languages. There were 100 participants from 2 different sites enrolled, had a pretty wide range of audibility and hearing loss, 29 to 79 dB HL, PTA. Also a wide age range, 32 to 79 years. And they were fit with Oticon More 1 hearing aids. Now, the important part here is that they were fit just in terms of audibility. Noise reduction and directionality features of the hearing aids were turned off for this, because ultimately later on we want to understand how the ACT could influence the implementation of those features down the road. So we'll see that in a little bit. But just to understand whether or not we can predict how somebody will perform when they have audibility restored versus the hearing aids. And that's what we were trying to understand here. Can ACT help to predict this? And we did this by administering the ACT test, but then also administering the hearing and noise test. Now, the hearing and noise test is both good and a bit challenging for this. It's a very good test to use to understand aided speech and noise in multiple cultures, because it has already been translated into multiple languages. So that means we can go to Japan and we can go to Germany and administer the hint and expect to get equivalent types of results. So that's why the hint stimuli were chosen. The challenge with using the hint is that it can be a little bit easy and you can get a feeling effect if you were to administer it in quiet, or if you just didn't have enough complex enough sounds. So what we really wanted to understand was, again, how somebody is going to perform when they are aided with hearing aids. And so an ecologically valid sound scene was created, where target was coming from the front at 65 dB SPL, and then interfering speech, somebody like a male talker mixed in, was presented combined with speech safe noise at 100 and 260 degrees behind the listener. And so this is like person behind you talking, there's background noise, but then there's also this interfering male speaker behind you while you're trying to listen to the person in front of you. And so this is designed to mimic a realistic type of cocktail party effect sound scene. So the test person was placed in the middle with the hearing aids on, and the noise was adjusted until they got their 60 or 50% correct score. And so that's the explained, that's the SRT that was measured. And so what you can see here was actually the amount of the SRT variance that was explained by each of test values alone. So on the left, you have the ACT test value alone and how much it predicted the person's outcome on that speech test. You have the pure tone average next to it, and then you have age. And independently, every one of those, including age, which had a small effect, but it was an effect, and it was a statistically significant effect. So each of those independently did correlate in some way with the person's speech and noise test. Now, however, ACT did have the highest correlation among those, or the highest level of variance was explained there. You can see pure tone average was also quite good, and ACT and pure tone average are really combined and sort of locked together in that you administer the ACT test at a stimulus level that is based on the pure tone average. So they're not independent variables by themselves, because ACT incorporates the pure tone average really into its rationale. But when you combine the ACT value the pure tone average and the person's age, you can actually explain more of the variance of the person's speech and noise performance with those three values together. And so ultimately, that is what the software is going to be using when we look at how to program the hearing and noise features in the Oticon Real or Intent hearing aids. It's going to be based off of those three values: the ACT score, the pure tone average, and the age. Now, if you didn't have the ACT value, of course, you can still program the Oticon devices. You could use the personalization strategy, or you could use just the pure tone average and the age alone. But as you can see, you're going to be able to predict more accurately what their function would be, and therefore predict their need for help in noise more accurately when you have the ACT score and when you combine the ACT score with pure tone average and age. So the second question that we really wanted to understand was about the relationship between the ACT values and speech understanding and noise in these two different real-life user groups. So as I mentioned, this was conducted in Germany and in Japan. And what you can see in this figure is the predicted speech and noise value versus the measured speech and noise value. So predicted based upon their ACT score and then measured in real life. Right here, you can see the distribution of the German participants, and so what their predicted versus actual was. And then I'm adding in now the Japanese participants. You can see there's a lot of overlap between the two. We really did not see differences in that relationship among the participants. And you can see that this is a really robust correlation between the predicted and that measured SRT and noise. So the ACT test did a really good job of predicting aided speech and noise performance into very diverse, very different linguistically diverse groups. Another important question that people tend to have is about test-retest reliability. In this study, they did retest within the same visit, and that retest was within 1 dB of in terms of the standard deviation. And importantly, the average test time in the study was found to be 100 seconds. This is something that is really important in terms of the clinical viability of the test, being able to ensure that we can consistently get a result for patients in a way that might be in some cases prohibitive in a clinical situation compared to a traditional speech and noise type of metric. So it's not a speech and noise test, but it does serve as a really nice proxy for predicting aided speech and noise performance. And it can do so in a pretty robust manner and in a very short time frame. And then the big question for us was whether ACT could provide a prescription that would lead to better outcomes than the current default settings in Genie. So again, the hearing and noise for Genie is set based on the person's age and their hearing loss and their audiogram pure average, but and you can further personalize that using the personalization settings. However, an alternative to that personalization process would be to use the ACT score and to personalize it further. But we wanted to ensure that that would lead us to the help that we're looking for. So you saw this a little bit earlier from Dr. Hughes, and basically the idea is that you've got this ACT value anywhere from -4 up to 16. -4 through +4 would indicate that you have normal or typical function in terms of that contrast level that's needed to hear the stimuli, and that would correlate with normal predicted performance. Mild is 4 to 7, moderate is 7 to 10, and severe is 10 to 16. And therefore, the more difficulty you have distinguishing that speech-like stimulus background noise, the more help you would theoretically need from the hearing aids in terms of separating out that speech from the background noise and improving the signal to noise ratio. Now, we evaluated that hypothesis using more sound intelligence in the MORE devices, Oticon MORE devices. More sound intelligence is the noise reduction strategy. It combines noise reduction, or directionality, and the deep neural network based noise reduction strategy. And the way that you can program the device has a lot of different permutations, particularly in the highest levels of technology. You can program the device to behave differently in simple environments compared to complex environments, and so on. So there's a lot of opportunity for personalization of the noise reduction settings. But for the purposes of being able to evaluate this in a research study, we need to make it a little more attractable to work with. And so those noise reduction settings were collapsed into 4 different groups. One was to turn them off altogether. The second was a low setting, which when it is activated, is the lowest level of signal to noise ratio enhancement. Then there was a moderate setting and a high setting. And so the details of those can be found in the white paper on audible contrast threshold, which we will also include in the chat for you in a little bit here. So we've got these 4 different help levels of the hearing aids. And then we have 3 different groups of people. So we had people who had good hearing and noise ability as predicted by an ACT test, moderate, or poor hearing and noise ability. So they were grouped into these 3 buckets depending on their ACT scores. And then we wanted to see how each of these groups performed with the 4 different help levels in the hearing. So what you can see here is you've got your 3 groups. On the left panel is the group that performed very well. The panel in the middle is the group that performed moderately, and then the panel on the right is the people that performed poorly on the ACT test. And then you can see under each of those panels, it says off, low, medium, and high. And what you're going to see is the score that they got on this y-axis here for each of those help settings. Now, before we show those results, I also want to show you this shaded section at the top, which is where people with normal hearing would perform. And so we want people to be able to communicate effectively with other people when they're using hearing aids. When people come in to see us, it's not because they can't hear. People don't really care about that. It's because they're having some type of problem predominantly related to communication. And so we want to ensure that people who are wearing hearing aids can indeed function on par with their normal hearing peers. Doesn't mean that they have normal hearing, but it would mean that they'd be able to communicate effectively with other folks who do have normal hearing. And so our goal is to get people up into that normal range performance category. So on the, whoops, I'm going in the wrong direction here, apologies. So with this group on the left, these were the people who performed well on the ACT test. So they had good performance. And what you can see is their performance increases as the noise reduction increases. However, they were actually able to get into that normal performance range on even the lowest help setting. And so with that, again, we want to ensure that people have a good signal to noise ratio so that they can get that good performance. But we want to do it at a level that doesn't overdo it in terms of the signal processing, because we want that signal processing to be as neat as possible. Anybody who's fit hearing aids knows that there's a trade-off in a lot of cases between benefit and satisfaction. That you can get really excellent benefit, but if it doesn't sound very good, patient might not necessarily be very happy with it. So we need to create that balance where they are satisfied and happy with the sound quality, but also getting the benefit that they need in order to be successful. And so for this group that had this normal or good performance on the ACT test, the low setting actually got us to that area. For the people who had a moderate score on the ACT performance, they fell into getting into that normal range with the medium setting, help level settings. And then the people who actually performed the poorest on the ACT didn't quite reach a range, even at the highest setting. So that tells us that those people would indeed need the highest setting to get the benefit that they're looking for. And then in addition to that, when they're in a challenging situation, could likely benefit from remote microphone technology as well in order to help them achieve what they want to achieve and get them closer to that normal performance level. So going forward, what we've done is incorporated this information and this knowledge into the Genie prescription so that based on the ACT score and the audiogram and the age, it will predict the speech and noise ability with amplification and prescribe the right help level as a starting place to be the most appropriate setting. Now, does that mean that this is the place that the person will end up forever? No, it doesn't mean that. You may find that based on our reports that they still would like some changes forward, but it does give us a much better starting place in order to get them closer to where they need to be. And in fact, in the study, we found that about 50% of the users would have received a different, more sound intelligence setting using their ACT score than would have just by the default of pure tone average and age alone. And this is something that gives us a lot of confidence that the ACT actually is providing a lot of value to the initial fitting for your patients. There is going to, again, be a white paper, so we should be putting that link into the chat for you. So you can go back and reference any of this information that you would like to and be able to use it with your patients. And so with that, we have a couple of frequently asked questions that people have a tendency to ask us. Dr. Hughes and I have done this session a few times here and there. And so we've had a few questions that are commonly asked, but I believe that we should also be getting some of these questions here in the chat. I see some of these are coming in. So let's see here. Ashley, do you want to go ahead and turn our microphone on as well?
Absolutely.
Awesome. So Ashley, this one's for you. The required test frequencies are something that I know that you mentioned, but then it's like those go by quickly. So you want to speak to those a little bit?
Absolutely. So the required test frequencies are going to cover the frequency range of the stimulus, the whole octave. So 250 hertz, 500 hertz, 1000, 2000, and 4000. If you have interactives there, that's great. It's not required, but you do have to have a minimum of those test frequencies. If you don't, when you go to the ACT screen, you'll see an alert that says something along the lines of insufficient audiometric information. That's just a cue to you to go back and just double check that 255, 1, 2, and 4 are completed on both ears.
Excellent. And then, of course, the required equipment that you would actually need if you were going to do that would be a compatible audiometer, the transducers, and then just the patient response button. So you're just going right in afterward, right? So, and instructing them right after the audiograms once you have those values, and just continue on with the testing. I know not all of us use a patient response button when we're testing, but for this one, you would want that patient response button so you can see they do actually respond. Correct, Ashley?
Correct. And actually, the software will automatically decide if it's a response or not. The response has to be within 200 and 600 milliseconds of the onset of the stimulus. It's really important that we trust what the software tells us. Sometimes with pure tone audiometric thresholds, we might say, oh, well, I saw the patient kind of jump a little bit or something, move a little bit, so I know they heard it. Because the software will automatically stop you when you hit the ACT value, it's important that we get those ascending trials appropriately. And so we're going to want to follow the guidance of whether the software has determined it to be a true response or not.
Absolutely. And then, of course, one of the big questions always is when I said, compatible audiometer, what is a compatible audiometer? And so you can actually see that list of compatible audiometers here on the screen. So the nice thing is these are all, you've got a range of companies that have audiometers that ACT is compatible with. So you've got the Interacoustics Affinity Compact, which is really where all these testing results came from and so on for the research. But it is also with several of the Medrex audiometers, and then the GSI AudioStar Pro version 2 and the GSI Hello. Now, the clinical study that I mentioned, that again we'll put in the link, that just was released from Henry Ford, they were using the GSI equipment. So when you look at video where we've included that link, you'll see it pre-performed on the Interacoustics audiometer, but it can be done on a range of types of equipment as well.
And one thing that I'd like to add that wasn't the case when this was finalized is it will be released on the Interacoustics Callisto within the month.
Oh, great. Okay. Thank you.
Well, that's some great information to add. Yes, thank you.
And I see we've got some questions here in the chat as well, correct?
Yes, yes. We have one question is when should someone use ACT versus QuickSyn, and what differentiates the two from each other?
Do you mind if I take this one, Ashley? Because I think this is such a great question, and a lot of people ask it. Okay, and it's such a great question because it really just gets to like any diagnostic test that we do. What's your objective? Like, what are you trying to do with the test? So there are a lot of differences between the QuickSyn and the ACT test. So for example, with the QuickSyn, you're using actual speech stimuli. And so if your goal is to really validate the patient's experience and help them when they say, you know, oh, I'm having a lot of trouble with hearing and noise. If you really wanted to have a speech stimuli that spoke to that and had a lot of good face validity for them, the QuickSyn is one way to go about that. The ACT test, because it's not a traditional speech stimulus, it's a like stimulus, it doesn't quite have that same immediate translation for the patient. That said, you can counsel the patient that this is a type of sound that will help me understand how well you can understand speech. But it does, the QuickSyn does have that sort of more immediate face validity for the patient in terms of being a speech stimulus. This QuickSyn can also be used more readily as an outcome measure. So if you wanted to see, for example, what a person's QuickSyn score was before they were aided and then after they were aided, you might be able to compare those values, for example, because you're doing it actually under an aided condition. In contrast, the ACT test is really done proactively to predict what that aided outcome would be. And so it's a different type of test altogether because its goal is to predict aided performance rather than to measure aided performance directly. In terms of audibility, this is where I think in particular the ACT test is very impactful, because the QuickSyn, unless you are actually testing aided, when you are testing unaided, you can't really make up for audibility loss across the audiogram. Hearing losses are configured, and so you don't really, there's no way to actually account for the audibility loss of the person across the frequency range. You can get most of the signal potentially supra-threshold, but it's going to be unevenly amplified. With the ACT test, it's going to ensure audibility across the frequency range because it's based on what the person's audiometric thresholds are, and then you have audibility above that. That's really what the audible in audible contrast threshold stands for, because again, it's meant to predict aided performance, and so you're automatically adjusting for that person's hearing loss and creating audibility across the frequency spectrum. And so you can get a better, quicker sense of what their aided performance might be. So I think QuickSyn as more like you can get a sense of unaided versus aided, but it doesn't necessarily help you to understand what the predicted aided performance should be. and then how to use that information to program your devices appropriately.
Great. And we have
Anything?
another question here. Oh, I'm sorry. Did you want to
Yeah,
add something?
no, I was just asking Ashley if she wanted to add anything.
I think that was perfect.
Okay, gotcha.
Okay, we have another question here from an attendee. What standard phrase do you usually use to condition the patient to perform the ACT test?
Do you mind if I take this one?
Please.
Okay, so there is actually going to be built-in instructions within your equipment that you can just follow along and read, along with one of the key parts is you're going to want to present the stimuli to the patient so that they know what they're listening for. So you can literally just read through it. It's a good idea with any test for us to give consistent instructions to all of our patients. Play the stimuli for them, make sure that they don't need to re-listen to any of them before starting the test, but you'll be able to follow that workflow through the equipment.
And then we have another question. Up to what degree of hearing loss can ACT be performed, given that it is a suprathreshold test? And they go on to say, I've had a number of patients with moderate, usually more flat losses that indicate that they can't hear the siren noise, even when presented by itself as an example during instruction. So up to what degree of hearing loss can ACT be performed is the main question there.
So it's not based on the degree of loss because we're looking at a limited bandwidth. So if it's a more severe to profound loss, but it's not within that 250 to 4,000 hertz, it's not going to impact the presentation level. If the hearing loss is too severe to reach 15 dB SL across the frequency range of the stimulus, you'll get a notification in the software that says, unable to reach desired output, would you like to proceed? And then you can choose to continue, but you're going to want to proceed with caution with the understanding that the value, the guide for the values isn't necessarily going to hold true for those patients where we are unable to reach super threshold. However, if it's able to reach super threshold, then you should be able to perform it with those patients in most situations.
And this was a really good question. It came up also in a webinar where they were actually speaking with the clinician who would perform this at Henry Ford as well. Their reports, so they actually tested 108 patients, and 100 of them were able to perform the test. So there were 8 patients who weren't able to perform the test. One of them, it was a language barrier to the extent where they couldn't explain the instructions. And so that's actually feedback we've given to Interacoustics is potentially down the road to include some verbal instructions in other languages, so that even if you don't have enough language similarity, that you would be able to do that. But in general, though, they were able to conduct the test even on people where English wasn't their first language, but they understood them well enough to be able to understand the instructions. And when they were asked this question, they said, yeah, there were a few people where the hearing loss was so severe that they just couldn't condition to the task. And when that was the case, they weren't able to do that. But it was a pretty small number out of the overall level that they tested. So it does seem like, you know, with very severe hearing loss, that may be the case. But again, to Ashley's point, it's not just the hearing loss, it's the contrast loss too, right? So they're taking that contrast loss on top of the hearing loss. And if they have a very poor contrast loss where they need like more than 16 dB between the signal and the background noise in order to hear it, that might be where they can't condition to the task rather than hearing loss per se. Does that make sense? Well, I don't know who I'm talking to, so sorry. I hope that makes sense.
All right, it looks like we have time for about one more question. How about this one? Can the ACT test be performed with visual reinforcement and conditioned play approaches?
At this time, it cannot, because again, we're really relying on that patient response button. That's what the software is looking for, is the proximity of that to the onset of the stimulus. So at this point, it's going to work primarily for patients who are mature enough to press the understand the task and press the response button.
Yep. And it is really about adults, and that's where we've seen this test validated. However, there is ongoing work being conducted to understand performance in pediatric populations. There's also work where we're trying to understand performance using electrophysiology rather than behavioral responses as well. So that will take some time to develop that evidence base as well, but it's on its way.
All right, I think we might have time for one more question to squeeze in. If I use real ear measurement in my daily hearing aid fitting practice, what benefits can I gain from using this new approach?
Virginia,
Excellent. Oh, go ahead. Yeah, sorry, go ahead, Ashley.
okay. I will jump in and then you can add anything, of course, that you want
Absolutely.
afterwards.
Yes.
So remember at the beginning, we talked about how the pure tone audiometry, we could think of that as kind of the quantity of the patient's hearing and ACT as the quality of the patient's hearing. So we're still going to do real ear measurements. We're still going to make sure that our hearing aids are fit appropriately for the age of the patient, the size of their ear, all of those things. Now we have another objective test that can guide us in a different part of the hearing aid fitting, and that's setting those advanced features on the hearing aids.
That's exactly right, Ashley. Yeah, because the real ear measures fundamentally are about gain. And not to diminish the importance of gain. Gain is really important for audibility, but real ear measures only tell us about gain. They don't tell us how to fit the those targets. For example, don't tell us how to program for the noise reduction, directionality, and so on. That's where the ACT test gives us really the first I'm aware of evidence base for a particular hearing aid to be set to particular settings for an individual patient.
Okay, great. Thank you so much. I believe that's all the time we have for today. Thank you for attending the webinar, Beyond Audiograms, Revolutionizing Hearing Aid Fitting with the ACT Test. Thank you to our speakers, Ashley Hughes and Virginia Ramachandran, and to Oticon and Interacoustics for sponsoring this informative webinar. A recording of this webinar will be available on the Hearing Review website, and please be sure to answer the post-webinar survey. Thank you, everyone.
Thank you.
Thank you.